We now move on to measures of central tendency, and that usually you call it the average. Now, the average of data, you can have three ways of representing it, depending on different situations, which we will talk through with examples. The first one being mode. The mode is the most occurring value, or the value that repeats the most. Okay. The median is the middle value of an ordered list, as we have seen before. And the mean is when you add up all the values and you divide by the number of values that are there, which what we know as the most common use of the average, right? Selecting which of these requires some thought, as each measure may be appropriate than the other in terms of different situations. Let's look at example 1, where we're told to find the mode in a discrete frequency table and the modal class from a grouped frequency table. When you're looking at a discrete table, the mode is quite simply the value that is repeated the most. That means what score has happened the most amount of times, which means what score has the highest frequency. And we see that the highest frequency is 6 of the score of 2. Therefore, the mode here is 2. Next, when you're told to find the modal class, in IGCSE, when we wanted to find the modal class, we just saw which class had the most number of frequency in that class. But remember, in IGCSE, all classes had equal width. Now we are looking at classes which have different widths. And remember, to standardize those classes, we use what we call the frequency density. So actually now the modal class, when it comes to A levels, is found by the group that has the highest frequency density. So think of the modal class visually as the class that has the most like density points, like there's so many points like grouped together and compressed within that class. The most compressed group is going to be the one that is the modal class. Okay, so we have these three groups here. We can find the frequency density for all of them. Here what we'll have to do first is make these groups into continuous groups. As you can see, we are missing the 7 to 8. And so what we do is create a lower and upper bound, where you will add the half of the difference between the two groups. So here the difference between the two groups is 1 from 7 to 8. And you will add half and subtract half to make the lower bound and upper bound. So the first group will just become 3.5 up to 7.5. Second group will be 7.5 up to 10.5. And the third group will be 10.5 up to 12.5. Here remember, the frequency is 100, frequency is 90, frequency is 80. When you're looking at the density now, we will take 100 divided by the class width, which here is 4. Therefore, the frequency density will be 25. Same thing here, frequency is 90, width is 3. Therefore, the frequency density will be 30. And here, frequency is 80, width is 2. Therefore, the frequency density will be 40. Therefore, the modal class here is actually the class from 11 to 12, even though it has the least number of data points within it. But because it has the highest frequency density of all the other classes. So the modal class here is the class from 11 to 12 centimeters given to the nearest centimeter. Or you write it in terms of our estimated thing. So the modal class is from 10.5 to 12.5. Next, we're told to find the modal class of the following example. Two classes of data have interval width in the ratio 3:2. Given that there is no modal class and that the frequency of the first class is 48, find the frequency of the second class. So firstly, we need to understand what this means. What does it mean when they say that there is no modal class? This just means that all the classes have the same frequency, or remember in A levels what we do is frequency densities. And therefore these two classes, because there is no modal class between them, they will have to have the same frequency density. Therefore, the first class frequency is 48, where the width of it was 3. Okay, we're going to use a ratio as our width. And what we'll get as our frequency density is 48 divided by 3, which is going to be 16. That frequency density will be the same one for the second one as well, second class. But remember, the interval here is 2, has a width of 2. Therefore, the frequency from this will be just 16, which is the density, multiplied by 2, which is the class width, which is going to give us 32 as our frequency. Therefore, the frequency of the second class is going to be 32. Then we move on to mean. The mean is also known as the arithmetic mean, where it's the sum of the values divided by the total number of values that are there. And you need to get used to the notation right here, where the mean of discrete data is equal to the sum of all the individual data points divided by the number of data points that are there. Or when you're looking at the group data, then the mean of that group data is going to be the sum of all the data midpoints times the frequency divided by the total number of frequency. Why do we take the data midpoints? Remember, when we have classes, we have, for example, from 2 up to 4, and we're given the frequency of, let's say, 20 in this. If we want to find the average, what exact data point do we use from this class? Because remember, when you want to find the arithmetic mean, what we have to do is sum up all the data points. What data point do we use here? What we do is we take the average of that class, which we identify to be the midpoint. That's why we use 3 as our data point from this class. So we'll have 3 from here. Then what we will do is that 3 is repeated 20 times. That's how we get this numerator notation. Let's move on to examples. 5 laborers whose mean mass is 70.2 kilograms wish to go to the top of a building in a lift with some cement. Find the greatest mass of cement they can take if the lift has a maximum weight allowance of 500 kilograms. So if they have 5 with a mean mass of 70.2, which means 70.2 is equal to the total mass, or this right here, the sum of all the masses divided by 5, because you have 5 people. That means all of them in total weigh 70.2 times 5, which is 351 kilograms. That's their total mass. Therefore, in total, they can now take 500 minus 351, which is going to be 149 kilograms of cement. That's the maximum amount of cement that they can take in the lift, because all the 5 laborers in total weigh 351 kilograms. Next, we have told to find the mean of the 40 values of x given in the following table. This table right here, which has discrete values with each of them's frequency. What frequency means is the number of times that discrete value has been repeated. And so, if we have the data point of 31 with a frequency of 5, therefore that data point has been repeated 5 times. And so if you want to find the mean of those 40 values, what we will have to do is this right here, fx divided by the sum of the frequencies, which equals to 31 times 5 plus 32 times 7 plus 33 times 9 plus 34 times 8 plus 35 times 11. Because 31 was repeated 5 times, I am showing 31 5 times. And then 32 was repeated 7 times, I'm showing 32 7 times. And I'm adding all of them together. And then I'm dividing all of it by the total number of frequency, which is the addition of all of these, which ends up becoming 40. And then the answer we will get is 33.325. That's going to be the arithmetic mean of these 40 values of x. Let's move on to the next example. We're talking about combined sets of data. A large bag of sweets claims to have 72 sweets, having a total mass of 852.4. And a small bag of sweets claims to have 24 sweets, having a total mass of 282.8 grams. What is the mean mass of all the sweets together? And so we need to take the total mass of all the sweets together, divided by the number of all the sweets together. which means we're going to take 852.4 plus 282.8, which is going to be the mass of all the sweets together, divided by 72 plus 24, which is the total number of sweets that are there. This is going to equal to 473 over 40, which in decimals is just 11.825 grams. That's the mean mass of all the sweets together, which represents the average mass of one of those sweets when put all together. Next up, a family has 38 films on a DVD with a mean playing time of 1 hour and 32 minutes. They also have 26 films on a video cassette with a mean playing time of 2 hours and 4 minutes. Find the mean playing time of all the films in their collection. Again, similar to the previous example, where these 38 films have a mean playing time of 1 hour and 32. And so the total amount of playing time is going to be 1 hour, 32 minutes times 38. Similarly, for the video cassette, the total amount of playing time is going to be those 2 hours and 4 minutes multiplied by 26 films, because the mean average time is 2 hours and 4 minutes. And so the total number of playing time is that multiplied by 26. This is going to give us 58 hours and 16 minutes for the total amount of playing time on the DVD. And the total amount of playing time on the video cassette is going to be 53 hours and 44 minutes. And remember, in order to find the mean playing time of all the films, we'll take the total number of playing time, which is this added to this, divided by the total number of films, which is 38 plus 26. So we're going to have 58 hours, 16 minutes, plus 53 hours, 44 minutes, divided by 38 plus 26, which is going to be 64 films. And that's going to give us 112 divided by 64 films, which is going to give us 1 hour and 45 minutes as our mean playing time of all the films in that collection. The next example, we're told that coconuts are packed into 75 crates with 40 of a similar size in each crate. 46 of those crates contain coconuts with a total mass of 20 up to but not including 25 kilograms. Then 22 of those crates contain coconuts from 25 but not including 40 kilograms. And 7 of those crates contain coconuts with a total mass of 40 up to but not including 54 kilograms. Therefore, what we have is this. So 20 x 25. Then we have 25 less than or equal to x less than 40 kilograms. And then we have 40 less than or equal to x less than 54 kilograms. And there are 46 crates like this. There are 22 crates of this weight. And there are 7 crates of this weight. And each of those crates have 40 coconuts in them, of obviously this weight right here. Now we're told to calculate an estimate of the mean mass of a crate of coconuts. Remember, each of these crates have 40 coconuts. And this weight is the weight of the crate, because they tell us that the total mass is such. So when you want to find the mean mass of the crate of coconuts, we're going to use this as our data point. And remember, when you have group data, we're going to take the estimated data point, which is going to be right in between the upper bound and the lower bound. So the midpoint, which is going to be 22.5 kilograms here, which is going to be 32.5 kilograms here, and which is going to be 47 kilograms right here. So we're just going to have 22.5 kilograms of that crate multiplied by the number of crates, which is 46, plus 32.5 kilograms multiplied by 22 crates, plus 47 kilograms of the crate multiplied by 7 crates. And that we're going to divide it by 75 crates, which is going to give us the estimated mean mass of 1 crate of coconuts. This gives us that the average mass of a crate is 27.72 kilograms. Remember, that crate has 40 coconuts in it. And therefore, if you want to estimate the mean mass of each coconut, what we will do is take that weight of the crate, which is 27.72 kilograms, the average weight, the mean weight, and we're going to divide that by the number of coconuts that are there inside that crate, which is 40, which is going to give us each coconut to have an average mass of 0.693 kilograms or 693 grams. That's going to be the mean mass of one coconut. That's going to be the mean mass of one crate, which you obviously use to find that mean mass of the coconut. Now we go into coded data, specifically coded data with the addition or subtraction of a constant. So what coding a set of data means is that transforming all of the values using addition or subtraction of a number. And the result of doing so will have that original set of data now being called a set of coded data. This is used to make the numbers easier to work with, and we will see that in this example right here. So the following data represents the heights of 6 students measured to the nearest centimeters. These are the heights of those 6 students. And we're told to calculate the sum of x. You should know what this notation means by now, which is the sum of all the data points that we have. So 110 plus 120 plus 120 plus 150 plus 160 plus 180, which is going to end up giving us 840. And then we're told to find the mean of those heights, which is 840 divided by 6, which is just going to give us 140. So that's the mean height of one of those students. Now we're told to code the data using this formula where you want to subtract 100 to each of those data points. So 110 minus 100 is 10, 120 minus 100 is 20, 120 minus 100 is 20, then we get 50, then we get 60, then we get 80. As you can see, this group of data, it looks nicer to work with than the original one. But it will obviously give us different values, and let's see what it does give us. The summation of all those values, which is the addition of all those values, just gives us 10 plus 20 plus 20 plus 50 plus 60 plus 80. It will give us 240. And obviously the mean of those coded data, which will be just 240 divided by 6, will give us 40. And that is the mean of the coded data that we have. Now, if you see the mean of the original data, which is 140, and you see the mean of the coded data, which is 40, what do we notice? The difference is 100, which is exactly what we subtracted to give us that coded data. With that, what we get is the following formulas, where for ungrouped data, which is what we had right now, the mean of the original data points, which is x bar, this right here, is equal to the sum of the coded data divided by the number of coded data, which is the x bar of the coded data. So this right here is the x bar of the coded data plus the same number that you subtracted at the start. So if we take this and add 100 to it, which is what we subtracted from each of those data points, we will get what the original mean was. And similarly for the group data, obviously, using the different notations that we have, where we obviously have to take the midpoint to estimate that mean. And this formula can now be summarized by writing that x bar is equal to the mean of your coded data plus the value you subtracted to get your coded data. We have another example where we're told that the exact age of an individual boy is denoted by B, and the exact age of an individual girl is denoted by G. Exactly 5 years ago, the sum of the ages of 10 boys was 127 years. So in notation, they gave it to us where the sum of b minus 5 is 127. In exactly 5 years' time, the sum of the ages of 15 girls will be 351 years. So the summation of g plus 5 is 351. Now we're told to find the mean age today of those 10 boys, where we get that the mean of b, which is the mean of the ages today, is equal to the mean of the coded data, which is b minus 5, plus that constant, which is 5. So what we do get is the sum of b minus 5, which is 127, divided by 10, because there are 10 boys, plus 5. That's going to be the mean age of the boys. And this just gives us 17.7 years. That's the mean age today of those 10 boys. When you look at those 15 girls, and if we want their mean age today, so we want the G bar, which is the mean age of the girls today, that will be equal to the mean age of the girls in 5 years' time, minus that constant, which is 5, which will just be 351 divided by 15, which will be the mean age of the girls in 5 years' time, minus 5. And this will end up being 18.4 years. So that's the mean age of the boys right now, the 10 boys, and that's the mean age of the girls right now, the 15 girls. And to find the mean age today of the 10 boys and 15 girls combined, we can use the mean age today of the 10 boys individually and the 15 girls individually. How? We will just take 17.7 times 10, which is the total age of the boys right now, plus 18.4 times 15, which is the total age of the girls right now, divided by the total number of boys and girls they are combined, which is just 25. This is then just going to be 453 divided by 25, which will give us 18.12 years. That's going to be the mean age of the 10 boys and the 15 girls combined. Next, we're told that 40 values of x are coded in the following table, where the values of x minus 3 were given it in group data. From 0 up to 18 has a frequency of 9. From 18 up to 24 has a frequency of 13. And from 24 to 32 has a frequency of 8. And remember again, x bar is equal to, for group data, the sum of the coded data multiplied by the frequency divided by the sum of the frequency. So you're finding the mean here. Then you will just add the constant. So in this case, because we're subtracting the constant initially, what we will do to find the original mean is add the constant at the end. And so what we then do is take the sum of all the coded data multiplied by the frequency. Remember, because the coded data is grouped, we're going to take the midpoint as our estimate, representing the entire group. So of the group 0 to 18, our estimate midpoint of the data points that represents all of them in that group is going to be 9, which is the midpoint here. So 9 is going to be our representative from the x minus 3. Then we have to multiply by the number of times it's repeated, which is 9 times. Then we add and do the same thing, find the midpoint of 18 to 24, which is 21, multiply by 13, which is the frequency of that 21 happening. And then the last class, where the midpoint is going to be 28, and we multiply by 18, which is the frequency, divided by 40, which is just 9 plus 13 plus 18, which is the total number of frequencies that we have. Then we will add 3 to it, which was what we subtracted to get our coded data initially. And that will then give us our mean of the original data that we have before the coding. This then just gives us 858 divided by 40, which is just going to be 21.45, which is going to be the mean of the coded data. And then we will add 3 to that, which is what we subtracted initially to each data point to get our coded data. And that will give us 24.45, which is going to be our x bar. So the mean of the original data that we had. We can also code data using multiplication. So suppose we have the following data set, which is the monthly wages of 6 employees. The employees now receive a 20% pay rise but they must pay an extra $50 tax each month as well. Now, if you want to code that there, what we will do is we will take the 20% pay rise plus the original money, which is going to give us 120% of the original, which is just 1.2, multiplied by their original data point, which we can just write it as X. Then we will subtract 50 because that's what the tax that they have to pay. And therefore, the coded data will look something like this. So 1.2x minus 50. That will be the original data coded to reflect these changes. Then we're told to calculate the mean of the new salaries. And the mean of the new salaries, remember, the mean of the original salaries was 1,400. And so to find the mean of the new salaries, what we will do is just take 1.2 times that 1,400 minus 50. And what we get from here is going to be $1,630. So that's going to be our mean of the 1.2x minus 50. And what we get from that is the following formulas, where for ungrouped data, the original mean is equal to 1 over the constant that was multiplied. As you can see, the a is the constant that was multiplied to x, which in this case is our 1.2. So 1 over 1.2 times the mean of the coded data plus the constant that was added to the entire x term that was there. So in our example, obviously we did have the ungrouped data. As we see, there are no classes. What this would look like is the following. 1,400 is equal to 1 over 1.2 times the summation of 1.2x minus 50 divided by the total number, which was 6, plus 50. That's what that would look like. Now, obviously, the changes are made for group data, where remember the x is going to be an estimate, which is usually the midpoint of the class. These two formulas can be summarized in the following way, where x bar is equal to 1 over a multiplied by the mean of ax minus b plus b. That's how it can be summarized into for both the ungrouped and the grouped data. So slight mistake in the original set of notes, but this is the correct version. So I can rewrite that for you, where x bar is equal to 1 over a multiplied by the mean of ax minus b plus b. Remember, this brackets as a whole is multiplied to that 1 over a. Finally, for the 20 values of x summarized by the summation of 2x minus 3 is equal to 104, we have to find the original x bar. Now remember, x bar is equal to 1 over the constant that is multiplied to x, which is 2, multiplied by the mean of 2x minus 3, which is just the summation of 2x minus 3 divided by the total number of data points that are there, which in this case is 20. Then we will add our constant here, the one that was subtracted to the original data, which is 3. That's how we do it. So here we'll get is 1 over 2 multiplied by 104 over 20 plus 3, which just gives us 4.1, and that's going to be our x bar for this question right here.